All right, for those of you actually taking the time to try and do the proofs, remember you need them done before you can take the quiz tomorrow. But I will show you the work and go through some things so you can actually understand some of what you're looking at if you don't. We'll start with number 2 because number 1 we should have done together, but if not, you can see it up there. If you look at number 2, you have marked that, or given to you, that F is congruent to H. So you see those marked right there. And IG bisects FGH, which is the big angle here. So this little angle and this little angle are congruent with each other. Now, if you look at the proof on the right side, just saying that it bisects the angle FGH is not enough. We need to actually go ahead and say that angle IGF, which is here, is congruent to angle IGH, which is there. Okay, so as you're going through this, notice we have angle. Now we've said the second angle piece. And then the last thing we note is that IG is congruent to itself because they both use it. And that's the reflexive property that you see there. And there's your S. So once you have all those things, you would be able to say angle, angle, side. The two triangles congruent IFG and IHG. Okay, so you can see there the two-column proof and the way you would go about. If you look at number 3, for some of you this may be different, but for first period we left it like this. So then for the rest of you, I'll go back and change some things here in a second. But for first period we kept it as is. So EF was parallel to HG. Okay, that means that this top side and this bottom side are parallel, and normally you'd see the arrows there. And the reason they use that is because it allows you to say that this angle here and this angle here are congruent by alternate interior angles. So you'll notice in the flow chart as I come over here, here's the parallel, and then it leads to that idea, alternate interior angles. Okay. You're also given that F and H were 90 degrees right here, and you want to go ahead and say that that makes them congruent, definition of right triangles, because being both 90 degrees, you have that right triangle. Here at the bottom, again, you'll see that they share EG, and that's reflexive property. Again, a reflexive property all over this worksheet, used a bunch. And so from here, here, and here, if we do that in the right order, now the way I have them written, they're not quite in the right order, but it should be, if you look here, and let me change the color to make it a little bit different, we have angle, the 90-degree angle that they share. We have this angle that we said was congruent by the alternate interior angles, then they share that side. So angle, angle, side is the eventual congruent shortcut that you see. And, you know, even though my handwriting's a little messy, you see that right there. Okay, I'm going to flip to the next page, and on the next page I did not do them on the worksheet, so you'll have to be looking at the worksheet to match the triangles I'm talking about there. All right, if you look at number 4 in your worksheet, you have two triangles that are kind of connected, almost look like a parallelogram, maybe a little something like this. You have this going down there. You have AD, B, C. And so what they tell you, the given information, as you can see in the flow chart, is CB is congruent to AD. Okay, you'll notice the given. CB is parallel to DA. So not only are they congruent, but they're parallel. So again, this parallel shows up all the time, and the purpose is to get these as alternate interior angles marked on there. Almost every time we see these in pictures, that's what they are. Notice in the flow chart down here, we added the idea that BD is congruent to itself. That's reflexive. Although we did write it as BD congruent to DB because technically this top triangle rotates, and this angle here is going to come down to match that. C will come around to match A, and D right here, CDB if you will flip around and match with ABD. Okay, so that's one of the reasons order is important. But looking at the markings you made, we have side, that's given. Because of those parallel lines, we mark those alternate interior angles, A, and then the reflexive property, S. So notice in the end, congruent by SAS. Okay? All right, so we're going to look at number 5. I'm going to erase what I just drew there so we don't keep it on there. So you can go back and look if you're unsure. For number 5, you had something that looked perhaps a little bit like this if you're looking at it. Obviously not the best drawing, but just to give you an idea. You had D, C, B, and A. All right, and they gave us B is congruent to D, so here and here. They gave us AB is congruent to AD, and AC bisects BCD. So AC goes through, and this angle will make 2 marks because they're the second angle we've marked are all congruent. So if you notice, we're given the angle here. We're given the side here. The bisector, like we said, leads to these 2 angles being congruent, A. And then if you can see within the triangle, they're congruent by ASA. Okay? So these proofs are not really as difficult as you may think them to be once you actually write everything down and get into the process. Okay? All right, looking at number 6, 6 asks us to write a paragraph proof. So basically what we're going to be doing here is writing out what we're saying in either of the other proofs in a paragraph. And you can see there what we have. So this one kind of has some crossing going on, or let me change that to a black ink. So something to that effect, and you have A, C, D, E, B. Okay, and it says C is the midpoint of AC and BD. Okay, so that tells us several things. If this is a midpoint, it's going to tell us that AC and CE are congruent. And I'll switch that to red. All right, so let me change that a little bit. AC is congruent to CE. Also, it's cutting BC and CD in half. So we have all those congruent there. So if you notice in the paragraph, we say that it is given that C is the midpoint of BD and AE, then AC is congruent to CE, and BC is congruent to CD by the definition of a midpoint. So again, the paragraph proof is literally just saying the things that we're being told. Also, because C, you have vertical angles coming here, this angle is going to match that angle, and we say that in the next sentence. Angle ACB is congruent to angle ECD by the definition of vertical angles. Please don't say angle C is congruent to angle C. You can't do that because C has many angles coming out of it, so you can't just say it's C and assume people would know what exactly you mean. So in the same idea as the previous ones, we have now shown side, angle side, and we say that there at the bottom. Therefore, triangle ACB is congruent to triangle ECD by SAS congruence. Okay? So for the rest of these, I think we've gone over quite a few, and I hope you get the ideas. So I'm going to leave this posted here with the answers. There's a third slide here that we'll look at, so it can show you what you should have as your final answer. So I hope you at least took time to look at these videos, to go through a few of them, and then you can look at the rest of them up here as well. Okay?